Hello, everyone. Today, I want to share some information about infrastructure as a code in general, and in particular, the approach to why it's needed and why cloud formation is, way to go in AWS Cloud. So a little bit about myself. I'm a senior system engineer at Wepa, and Wepa is a leading cloud print solution provider among colleges and universities in the United States. And as a part of our Wepa team, my top priority is to make sure that Wepa is achieving the highest level of uptime and performance in our cloud infrastructure and across our big network of thousands of print stations. So, and also as the other side of this, my another priority is support the development pipelines, make sure that developers are able to deliver the code just easily and without any, interruptions. And of course, the main thing is just to make sure that whatever was tested in test environment has to behave the same in a production. And this is actually what it's all about. Infrastructure as a code, it's like repeatability. But I'll talk about this a little bit later. So in general, we all know that infrastructure as a code is an approach that taken when you just describe something as a text or a code and just you check it into like a version control environment, and that makes it like infrastructure as a code. But we all know that it was not like that from the beginning, and at first it was like just a manual, just instruction, hey, how to set up this, how to set up that. And of course, we all know that that's something that was really, there was a lot of room for mistakes, especially like human mistakes at any stage, any stage of that process. We were reading like detailed instruction, or it was then like copy paste commands. It was just better, but not that cool, right? There are, and especially when we just started to move our infrastructure into the cloud, then these questions, how to make it like really better, and just like the question just rise like on a higher level. So, and of course the clouds themselves, they have like web interfaces, so you can still like click and have it done, but again, it's not something that can be like repeatable something. And there are some commercial like third-party products that helps you to describe your infrastructure, and some of them like Terraform, and Pulumi. Terraform is tend to be like cloud agnostic, but technically it's in general it is, but still when you just describe particular cloud, every cloud has its own objects of infrastructure pieces, and this object have their own properties and their own behavior. So it's really not that thing other than just, you use Terraform to deploy, like in AWS, and you use Terraform to deploy into something else. So the same things with the Pulumi. So Terraform is more like templates, a YAML template, and you just describe infrastructure like that. It's similar to Cloud Formation, but Pulumi is more like coding. So you just, for example, doing Python code or like Java code, and then, but in general, it's not really different from just simple AWS CLI commands, just put into a text file and call like a script, like shell script, to create this, create that, and just have fun. Or there are like other products. But of course, before like looking for some third-party products, it's a good thing to look into native solutions. And native solutions in AWS clouds is, of course, AWS Cloud Formation. And Cloud Formation is a tool that helps you to describe and not only describe, but also deploy your infrastructure into AWS Cloud in a repeatable, error-prone way. So this is a good thing. But it's still just a cloud, it's just a YAML template when you look at that. But there is some magic behind of that helps to choose CloudFormation as a preferred thing. And of course, AWS also has a cloud development kit. Cloud development kit is a framework that helps you to actually generate a CloudFormation template, but with the help of just using your programming language skills. So for example, you just take your favorite language, just connect this framework as a library, and then start using the objects, create an EC2 instance, and that's it. Click, deploy, and it will create you a CloudFormation template. And the beauty of it is, CloudFormation Cloud Development Kit has 3 different levels of abstractions. And on a simplest level, a lot of the things goes by default. And for example, if you need just EC2 instance, you just create EC2 instance object, just use some mandatory properties you define in there, and the rest goes by default. And the CDK will generate you a CloudFormation template and then deploy it as a CloudFormation stack, and you have fun. But if you just have more precise things, then you have something already in your cloud, so you need to define more properties. Then you need to go down to the most detailed level of Cloud Development Kit, and there, every object in Cloud Development Kit is equal to object in CloudFormation. So it's actually no benefits. The code in CDK won't be shorter than the code in CloudFormation, and because most people just getting afraid of oh, the CloudFormation template is 2,000 lines. Is it like human readable or something? Is it understandable? So yeah, this just in general, and that's why I want to talk about CloudFormation in particular. And CloudFormation, not this presentation is tend to be more conversational, and I would like to actually answer some questions if you have ones, and also help you to start using the CloudFormation, even if you already have of course, everybody already, you already have something in production, everything's deployed, and not everything, is deployed using CloudFormation, or maybe some of you're just still in the beginning of this process and just considering CloudFormation or Terraform or something. And my goal is to just, make it easier, see the benefits of using CloudFormation, answer some questions, eliminate some fears related to just, hey, start using CloudFormation. What if it will do something that I do not expect from it? And just going this way. So does anybody have any questions at this stage? okay. Here I want to talk about Cloud Formation in general. So yes, as I said, the benefits of it is like simplifying infrastructure management, quickly replicate infrastructure. For example, if you want to like deploy it in another like region, that's easy, or even in another account. Or for example, you can quickly test something like some radical changes to infrastructure, but you want to just do not make any changes in your existing test environment and existing production environment. You can just quickly spin up and +1 test environment, test what you need, and just terminate it. And yeah, CloudFormation helps you easily control and track changes to infrastructure. The basic concept of CloudFormation are the following: as templates, stacks, and a change set. And I will talk about this concept a little bit more in the next slides. But here I want to say something about like how to start. I mean, it's obvious, that you won't start like from, when in most like how-to and examples, they just said, okay, they just start from the point when you have nothing. And then they say, okay, just do this and this and this, create VPC, create networks and everything. But most of the cases, like you already have a lot of this and it's already in production, and it will be a big deal to recreate it from scratch. So it's no need. But for example, you need right now to create another cluster of like a new application, or for example, you're making changes to existing cluster because existing cluster just has some kind of like performance issues or something. And in this case, you need to make these changes. And the question is whether you make those changes like usually, for example, using the web console or using like CLI scripts or something else, or you can just try, CloudFormation. And the thing is that, yes, it's like CloudFormation could seem to like, this is like too verbose. I have to be like really, really smart to remember all those 2000 lines and just, keep them in my head. But in reality, those like 2000 lines, they actually, it's, you do not look into that frequently, because once you just, for example, most of the, okay, let me stop. Yesterday, Huntsville AWS has a nice meeting about how to move your infrastructure into the cloud. And the key points in that action was actually, you have to make an audit of your infrastructure, then make a plan, and then start to move piece by piece, not everything at once. And these pieces that just getting moved into the cloud, they actually, some kind of clusters. It's a set of instances that run some application and just behind a load balancer. So in general, this is just the main infrastructure element that could be just taken as an example and describe it using CloudFormation. And the benefits of that would be that, this concept of like having a set of servers controlled by autoscale and control ASG, autoscale and group, and the traffic to that is controlled by load balancer. This is actually, I would say, like most of the clusters, most of the things we deliver to AWS look like that. So here we can say something like that. So once you create a CloudFormation template to deliver this like basic element of infrastructure, then others will be just similar to this. And once you have your like a dream template to deliver, this this particular any application cluster into the AWS, then you can reuse the same template to deploy other things. And of course, CloudFormation itself, it's not something that, it's not like self-sufficient. It's a great tool. It's perfect, but these benefits and the whole thing will work with if some assumptions are met. So, for example, there are like some prerequisites that you have to have in order to make it working. That's why this conversation has two parts, like the CloudFormation information about the CloudFormation itself, and information about important things that has to be achieved, important goals that has to be achieved in order to successfully to benefit from using of CloudFormation. So let's do you have anything to say or questions, anything about what I said? Okay. So AWS CloudFormation templates, let's talk about this a little bit. So CloudFormation template is a JSON or YAML text file, actually. It's a description of AWS infrastructure. And yes, I'm not showing you some kind of like working examples of that or something, just because, it's showing like 2,000 lines of a template or something like here. It's, it's hard to name helpful. So in general, this is the example of like the simplest, CloudFormation template. So you just need to have a resource description. In this case, it's like a resource type like S3 bucket, and the name of that, logical name of that resource, sorry, is my bucket, and the bucket name is test bucket. That's it. So as simple as that. And as long as you, deploy this one, you'll get your bucket created. And this text file is easy to save in source control, and but look, this is not what you are here for, like to look how to create a bucket, right? So we want to talk about something more complicated. And something more complicated is actually, for example, you need to deploy this. We are talking about the general cluster, and like cluster is, instead of instances, controlled by auto-scaling group. So of course we need to, instead of this S3 bucket, should be like, okay, auto-scaling group. And then auto-scaling group comes with some properties, some dependencies. So you need to have like a launch template, like AMI image, then some. The interesting part is, and the description of those parts could be found in this nice CloudFormation help website, and they have a lot of examples of anything you can create in the AWS using Cloud Formation. So actually everything could be created there. And here, for example, on the right side of this, it's a example how to create like EC2 instance. So like properties like image ID, like SSH key name, instance type, security groups, description of EBS drive that you want to mount. And in general, that's it. So this is the starting point. And I would recommend to have, for the like educational purpose, to have some kind of like separating, or at least, you know, the test account should be like, test environment should be under like separate AWS account. And starting small, getting used to use the Cloud Formation, kind of incremental approach. So when you use incremental approach, using something simple, then just add more bells and whistles, test it. And as I said, once you have your like dream template, this is not. This is something that you can replicate into other, spinning up other clusters. Personally, for me, it was really like iterative. You know, it was really like kind of not just a short-term process, because one day I thought, okay, this is kind of template that works. And I said, okay, I'm deploying it. Yeah, it works in test environment, everything's perfect. And then I deploy it in production. And then I do a couple of other clusters like that. And then I said, hey, I need to improve something. And yes, in this case, you know, you need to just make changes in all the templates that you already deployed. But we'll talk about the way how to do that a little bit later. So, but in general, that's all that I want to say about this particular part, because it's kind of endless conversation how to just this particular thing. So my goal is to just show you the general approach, and especially how to start, you know, how to start using Cloud Formation, even if you already have something done in a little bit like different way. So the next part of the Cloud Formation, it's a Cloud Formation stack. So what is Cloud Formation stack? Cloud Formation stack is a set of AWS resources that being created by Cloud Formation according to the description in the Cloud Formation template. That's pretty much it. And Cloud Formation always creates all these resources, keeping the dependencies in mind, and in a safe way. So and actually, when you, for example, when we talk about like EC2 instances, then of course you go to the instances tab in the web console and you see the list of instances. But when we talk about like Cloud Formation, you go to Cloud Formation page in AWS Web Console, and you can see there a list of deployed Cloud Formation stacks. That page actually has a very, it's pretty much informative. It has a lot of information about the stack that been deployed, the list of elements that being deployed, the order, the messages, or error messages or success messages that been produced during the creation of those elements. So when you talk about cloud formation stacks, there are two basic processes of stacks that stacks are involved into. It's a creation process and the update process. We don't talk about much about like delete process. That's obvious, but I want to talk more about the update process. Update process. This is something that makes cloud formation is like, I would say, noticeable. Like it makes it different from other third-party product that helps you to describe infrastructure. First of all, cloud formation remembers the state of the stack that's been deployed, and it just does it automatically. Other products want you to pay money for that, or just you have to share the text file that has like a description of current state that has been deployed, because it's easier when you just creating the stack from scratch. But when you just making changes, of course, the system that makes changes, of course, should have a valid starting point. And the biggest problem here could happen in case the description of the starting point is actually different from the real situation. So resources being changed like manually or something else, and this is my problem. So in case of cloud formation, it's for example, it's easy to collaborate when team is like distributed and working remotely, and you don't need to share this particular file or just check in, check out. It's like a state file about how things are already deployed. So in general, the update process consists of like 5 main stages. Like you edit the template, then you create a cloud formation change set based on your modified template and input parameter values. And of course, the delta being generated between your modified template and the previous template that had been already deployed. So then,
hey Sergey, I have a quick question.
Yeah.
Is there a way that you can tell that resources that you've created have been modified outside of the code process?
I would say no. In case, so there are like 2 types of changes that being made outside of the process. So for example, there are something like non-important changes that you've made. And then in this case, for example, you just like change the number of instances in the scaling group like manual. You just like quickly just increase the maximum number of instances because you just need it right now. And this is something that will not disrupt the further like deployments, because the further deployments, they will actually reset this particular value, right? But in case you just went ahead and deleted the source AMI that you want to use, or that been used to deploy this particular thing, then it's kind of, or delete some resources. That is very, very important. So in this case, the deployment will just, won't succeed. And the thing is that cloud formation, the magic I mentioned previously, the magic actually happens in this particular place. So cloud formation is trying to be like very, very careful when it's making changes to your stack. It just tries to apply changes one by one. And if it's not able to do something because of different reasons, then it just tries to safely roll back because it knows the state you want to bring it to. It remembers the stack it used to be into, and then it creates a change set. So it rolls back all the transactions that been done from the moment when the problem happened till the initial state. In some rare cases, that initial state cannot be achieved. And I want to talk about this particular case like a little bit later, and especially about the thing that should, I mean, it's not things, it's just some processes that you should acquire before in order to make it happen. But at this particular moment, I'm going to say that this is what it is. So it's kind of, so did I answer your question?
Yeah, I appreciate it. Thanks.
Okay, cool. Just trying to check the chat. Okay, so the change set. And then this change set is actually being deployed. So when we talk about the creation of a stack, we take a template and we just deploy it. When we talk about updates, then we take a template. Based on this template, Cloud Formation creates a change set for us. And then this change set is being deployed. So it's a little bit different. And here, the next slide, I want to talk about the immutable infrastructure. So immutable infrastructure is an approach that actually helps you to achieve the best everything, like best uptime, best, deployment processes, like avoiding the mistakes, and here on this page, I listed like the most important like benefits of that. So it's reduction in configuration breadth. So it means that known state. So if you deploy something into production, it's exactly the same thing that being deployed to test environment, and it behaves exactly like that. So the configuration is exactly the same, and this is like very important. The second thing is like simplified deployments. Upgrades are just another deployments. What does it mean? So for example, if you deployed like AMI version 2 instead of AMI version 1, and then, yeah, deployment was fine and everything was perfect, but oops, something like, something was missed and you just need to like downgrade, for example, then you just deploy version number 1, or you want to deploy version number 3, is just deploy version number 3. Reliable deployments, it's all or nothing. What does it mean? So this particular, we previously were talking about the change set, and change set is something that is being delivered, or everything is like getting rolled back. If like recently, Cloud Formation made the changes like this August. The Cloud Formation allowed us to change this behavior. So for example, if it's like a test environment, and if the deployment problem happened, you probably would like to pause this deployment and just being able to look into that, because once everything is like up and running and it's just happens by itself, then you not actually getting, you're not controlling every deployment that's happening in your environment. It's like you automated it. And if a problem happened, it would be cool if you just can go look what exactly happened at this particular time, other than just because, for example, until now, so I had to, if something happened in a dev environment during deployment, I was notified, and then, okay, I need to, at the time, for example, sometimes I'm kind of delayed on something else. And at the time when I just get to that, oops, AWS already like rolled back all the problems. And it's beneficial because it's like a test environment. Test environment is, it's a system with multiple components. And for example, if component A is failed, like deployment of new version of component A failed, and engineers cannot just take care of this right now, then other process won't be interrupted or blocked because, okay, this particular deployment just rolled back, and other companies could be still tested with everything. So, safer deployments with a fast rollback and recovery process. This is a canary blue-green approaches. And canary is an approach when you just deploy, for example, like non-significant. Okay, if you have like 10 machines in this cluster, then you just update the first one, everything's cool, you just tested this particular one, and then you just update all others. And blue-green is when you just have a cluster and you just have it running under version 1, and then you deploy another cluster running version 2, and then you just make sure it's good, and then you just switch traffic from cluster blue cluster, the old cluster, or to the green cluster, the new one. And again, here I want to talk about this a little bit later. So here possible different approaches. Even with this like blue-green approach, it could be done in a canary style. So it's like AWS magic. Previous it was just like DNS magic, and now we have load balancer. Load balancer help to do that as well. Consistent test environment. It's one build is deployed to multiple environments. And yeah, I just want to mention that here, like immutable infrastructure, it actually starts from, if you talk about servers, then like instances, EC2 instances, then they keeping in mind they were like immutable, then the instances have to be like immutable as well. So, and we'll talk about this just in the next slide. So, and it means that inconsistent test environment means that you take this AMI, you deploy it in dev, test it, everything's cool, and you can deploy it in prod. And of course, in prod, it, increases scalability. In prod, this AMI will be multiplied many, for example, you need like 100 instances, and boom, you have 100 instances, and you're not in fear that, oh, something will go wrong if I deploy like 5 more instances of this, because I don't know, something like network resource won't be available at the time the new instance is starting or something else. So this helps to make auto scaling and replicating environments very easier. Simplified toolchain. No more configuration management systems. Configuration management systems, these are systems like Chef, Puppet, Salt, and the goal of that is just to the same thing, infrastructure as a code, but they were created for a little bit different purpose and everything. But the thing is that initial idea would be, hey, yeah, let's just create this AMIs, or whatever, using this configuration management system, because previously when we were running on our infrastructure was running on premises and like in real data center, not virtual data center, then yes, in this case, all those tools, they helped us to, eliminate the human mistakes, because they were doing the same things human were doing, but they were doing it like automatically, and they were previously tested for this particular thing. In this case, just, simply no need to make it that complicated. Just, for example, if you just need a web server, then okay, when you create the new AMI for this particular service, okay, just say, okay, Ubuntu, okay, apt install nginx init PHP, just install PHP needed branch at the moment of the image creation. That's it. It's, just why make it more complicated? And increase its security, yes. This is something, okay, I'm not saying you should, but you can even disable SSH, because no real need to just go to this inside of this instances and do something. But most of these instances, they just inside of your cloud and just inside of the VPC. So it's just, in general, this is more for, and even if it's enabled, it's still firewalled, but for, but in general, that's possible, because once this approach is acquired, then the need to go inside of particular instance is a very, very, like, it's significantly decreased. So,
hey, Sergey, let me interrupt for just a second. We are about 12 minutes from the hour, so I wanted to, if we could pause for a second and give people opportunity for a few questions, and then for those, that way, if there are people that have to jump off at the hour, maybe field a few questions. But for anybody, Sergey, if you want to hang out past the hour, we're happy to continue on, and anybody who wants to hang out past 12, if y'all want to do that, totally great. But I did want to make sure that we give everybody an opportunity for some feedback before they might have to jump off at 1 p.m.
Okay. So actually, I wanted to just just a couple of important, I need just maybe 2 minutes.
Sure, go ahead.
So I kept mentioning about Immutable Sewer, and what does it mean? It's a built from a base image by an automated pipeline. Included all the dependencies needed to operate, so without a need to pull anything from internet at the start. Initialized by a startup script, and this is startup script. It's kind of, if you know how use Docker, then Docker images usually have entry point, and the entry point is the script that is actually starts all the services on this particular instance, and it's taken in run variables from the. Okay, it is the biggest assumption of the startup script is that environment variables already exist, and configuration parameters are injected into the startup script at start. So so for example, this is how you can just differentiate the CloudFormation template that is kind of more like universal from a particular instance startup script. So the startup script and CloudFormation template would be just pull in the parameters for this particular service and then run the entry point .sh script that being placed by you at the image creation. So at this point, everything will be just it's kind of encapsulation. So everything that is like image related or service related inside of that image creation process. So AWS parameter store is our friend here. And of course, would be nice if this particular server would be like stateless. So the service would be stateless. Of course, some, not everything is like, but if you talk about like general web server, then we can say that, okay, let's just use like Redis or Memcache. That is also AWS provides a service like that. And in this case, you can just create new instances, remove other instances very quickly. So, and here is like immutable deployment patterns. There's like two main deployment approaches, like canary deployment and blue-green deployment, and they could be combined. And the AWS provides the ways to like use it for like Route 53. You can use like if it's like another the new cluster is behind a load balancer, then you can just route the traffic to the new load balancer using Route 53. Or it could be like multiple auto-scaling groups. So you deploy another auto-scaling group with another. So, and yeah, the thing is like you have template and you just have it and you want to deploy it again. I mean, you just want to deploy it like a green version. So just change the name of the stack in that template and then deploy it. And then you have everything like you already have, but just deploy it as another Cloud Formation stack. In this case, you have an option. So for example, you can add new instances from the new stack into the same target group of load balancer or to another target group of load balancer. And then you can use like ALB plus weighted target groups. So you can switch traffic inside of ALB using target group magic and so on. So there are numerous of things. And the final slide is actually kind of readiness check. It's kind of a little plan to just for the this approach to succeed. It's infrastructure as a code, but here we talk about the description of particular cloud infrastructure. And I'm not saying that you cannot do this without CloudFormation, but using CloudFormation simplifies. If you talk about like AWS deployments, it simplifies things a lot in comparison like Terraform. So centralized monitoring and logging in case of in case of like AWS, it's a CloudWatch. So CloudWatch is a perfect thing. And for example, in my clusters, I deploy the CloudWatch agent on every instance, and it's actually not in the entry point that I've been talking about. It's just after that. So the template is actually injecting environment variables, runs entry point, and then it starts the agent on the instance that has been started. But the agents are pulled from AWS, and it's pretty much reliable thing. Deployment automation using immutable deployment patterns. This is something that yes, I talked previously. It's about like blue-green deployment, golden image creation, and update pipeline. So yes, in order to talk about CloudFormation and automation and auto scaling and everything, this is the artifact that we deploy to the cloud should be the image. So if you have like a website version 2, then the website version 3 is just another MEI image. Again, this is like a limited case because we're talking about something that reasonable to run as an EC2 instance. I'm not talking about like cloud native applications or something else. In this particular case, I'm just talking about this thing. I'm not saying that's not possible to use the cloud formation for deploying, for example, like EKS services, EKS task, I mean, elastic container services in cloud formation in AWS. That's possible. I use it for that as well, but you know, for this limited scope, I just want to say that, you know, in that case, the artifact would be again Docker image that has everything and the version. So here the same approach, just different, you know, different in like stateless application layer. Not all the application just stateless, and it's just up to the infrastructure engineers to think how to make them like stateless or something. Because if the instance that is in the auto scaling group, okay, if you can just go like kill it and nothing will suffer, then you can benefit a lot from these approaches. And this is about like in-memory data stores and everything. I mean, in-memory data stores is like Redis and Memcache that is external relations to this particular instance. Why that's important? As a like a cherry up on top of this cake, I want to mention about the biggest benefit from the whole thing. So, for example, yes, you have cloud formation, you have this, yes, you can auto scale in, you can have auto scale and everything, but you can also significantly cut the expenses for the infrastructure if you implement this approach, because it would be easy to start using spot instances here. And this is something that makes the whole thing just worse to be done, to be, you know, this is something cool. Okay, thank you. I'm sorry, I was a little bit longer than 2 minutes, but that's pretty much. I'm open to answer questions.
That was great. Thanks a lot, Sergiy. For anybody that needs to jump, thanks again for joining. We'll be back here the 28th next month, but love for anybody to stick around that's got any questions. Please have at it.
You could have a question there, John. You can just come off mute if you want to ask it.
Hey, so yeah, I have a question. Can everyone hear me okay? I'm on my headphones here, so.
What?
Sorry,
Yeah,
can
we
you guys
can hear
hear me
you.
okay?
Yeah.
Okay, cool. So when I think about like infrastructure as code, or I guess maybe just like infrastructure in general, you know, I think about like servers, maybe like network load balancer, so like EC2, you know, network load balancer, VPC, stuff like that in that kind of service. But can you talk about like how you use infrastructure as code with serverless architectures? We have a tech stack right now that's built out of APIs and they call and Lambda functions and read and write from Redshift cluster. But I'm curious as to how we can leverage Cloud Formation when we're dealing with serverless managed services. If you could go into that, toss that question up to anyone. Thank you.
Okay. Okay. In this game, the key thing to the key to success is in definition of the deployable artifact. So when we talk about EC2, I talk about that. I've been talking about that. the artifact that we deploy is not a file placed to an instance, it's the image of an instance. So when you talk about like serverless, there are two types of serverless things in AWS. It's just the Docker containers, or it's in Lambda functions, right? And both of them, it's possible to use CloudFormation to deploy both of them. But in case of Elastic Container Service, we need to talk about the Docker images. So you need to bake a Docker image, place it into a container registry of AWS, and then CloudFormation actually, but again, it's not that just like you have nothing and then you just have one template and then you just keep deployed something. Because, for example, if you talk about like Elastic Container Service, I bet that this particular service will not be the only that you just deploying. So there will be another services that you want to deploy next to this, right? To the same like Elastic Container Service. So every of this process should be like wrapped up as a separate CloudFormation template. It's kind of separate pipeline. So, and of course, for example, in my case, I thought, okay, I need to create the Elastic Container Service. Okay, and I just went ahead and created the Elastic Container Service template that creates me the EKS that I want. Then I needed to create deploy a service. For example, like what is, for example, I have a script that runs like 10 hours and it just needed to run somewhere, but I want it to be like separated from anything. I mean, there are used to run it like on a big machine among other scripts, but you want to like a separate deployment to this particular script. So it's wrapped up as a Docker container. So you have container with a Python modules and this script, right? So you have this container and the container is created from an image. So you create the image and then you create a template that takes the name of the cluster as a parameter, and then deploys it. So the key here is CloudFormation. I didn't mention that, but CloudFormation also the main part of this, and it's a parameters of CloudFormation template. And there you can define, this is actually the connecting points to the existing infrastructure. So you just say, okay, I want this cluster, I want to use like deploy it into this network and everything. And the same with a Lambda. With a Lambda function, the deployable artifact, okay, what actually changes when you deploy a new Lambda? Okay, the deployable artifact is just, is actually a zip file, place it in S3 bucket, and then a Lambda, using the CloudFormation template, you just say, okay, hey Lambda, the new version of whatever you're running is in this bucket under this name. That's it. And that's kind of one of the ways to do it. And if you talk about Lambda, then Lambda, if you need to look into like a deployment manager in AWS, it provides a way how to use the blue-green deployments for Lambda specifically. And but again, that's all thing is actually possible to control from CloudFormation. But maybe from the beginning, but again, CloudFormation is actually, there is a point in time when you just tired of like clicking all this like web interface buttons or something. And then you're just saying, okay, I just need something that, I just need to provide a magic button to the, developers to like click a button and get it deployed. Okay, you just committed the code, right? And once the code is committed, then a trigger happened, and your CI server pulled that commit and just created the deployable artifact from all of that. And then that deployable artifact being delivered into your infrastructure at 24/7. So you as a like deployment engineer, you just provider of magic button. You're not like physically deploying anything. And this helps you to, perform very well. So that's very much. I mean, it's like increase effectiveness other than just like, increase the scale, like vertical scale, and I would say like that, like horizontal scale, and when you just need more engineers to make more deployments, and like vertical scale, you just have like more like skilled engineer, and he can just manage to create some robots that deploy these things for you.
Okay, thank you.
Yeah, but the main answer is like definition of a deployable artifact is the key here.